Okay, so now that we've had the opportunity to take a look at how the series circuits work and how the parallel circuits work, let's kind of summarize the rules for the big three electrical properties. And that's going to be, of course, the voltage, the current, and the resistance of the circuit. So let's make a little table. That's probably the easiest way for us to do it. So let's make a space for the property and the two circuit types. So we have series. We want to give plenty of space for this. Use your whole paper, because we do have a little bit to write in this section. So the three big properties are the voltage, the current, and the resistance. Okay, so the rule for series when we looked at the voltage was that since the charges can only, or the resistors I should say, can only use up a small amount of the energy from those charges, they share the voltage, or that is to say they share the energy. The battery is the source of the energy, and then they have to split it up. They don't get all of the energy. Each individual resistor only gets a small portion of the resistance, of the energy, I should say. So it would be V1 plus V2 plus V3 plus whatever number of resistors that we have in that circuit. Now in parallel, the rule is a little bit different because each individual resistor will get the full value of the voltage. Since there are multiple paths, but there is only one way to get through the resistors, in one individual pass, each one of the resistors gets the full value of the charges that goes through it, but it doesn't get all the charges. That's the trade-off. So while it gets to take all of the energy from that particular group of charges, those are not all the charges that are moving through the circuit. Some of them are moving through the circuit, and they are not going through those particular resistors. So these two rules flip when we go to the current. So where here we had to share the voltage, the current does not have to be shared. Because the series circuit only has one path, everybody gets the same current. They get the full value of the current from the battery. But because we do have separate paths, now we are splitting up the current, and it will have to add up to what came out of the battery. So if we have three paths, we would add up the current in those individual paths, and we would find that they add up to the current of the battery. Okay, so those rules came from the law of conservation of energy. This is all the rules for voltages came out of the law of conservation of energy. All the rules for charge came out of the law for conservation of charge. You know, it's really just applying that basic principle and basically common sense to, you know, what is possible to work in this particular situation. Now, the rules for resistance are not necessarily quite as obvious, but the way we came up with these rules was by applying what we understand about voltage and current to derive rules for the series and parallel circuits. So in this case, the resistance, Req, is equal to R1 plus R2 plus R3 plus whatever number of resistors you have in that circuit. And then in the parallel circuit, it's quite a bit more complicated calculation. It's actually, the equation is the reciprocal of the equivalent resistance would be equal to 1 over R1 plus 1 over R2 plus 1 over R3, or however many number of resistors that you have in that particular circuit. So that's that was a little bit more tricky calculation, but still the math is not that complicated. And when you have a pure parallel or a pure series circuits, then these are the way that the rules are going to work out for them.